Hello everyone and welcome back to our channel Quaint. What happens in our digital world? You know that hacking is just a game of copying. Copying passwords, copying keys, copying secrets. But in the world of quantum physics, something strange happens. Yes, something fascinating happens in the world of quantum physics. The nature or the universe itself says copying is forbidden. Yes, nature itself prevents the act of copying, and this happens in the world of quantum physics, or more specifically in our today's video we are discussing actually about quantum communication networks. So in quantum communication, nature itself the act of copying. In case of classical computing, you know that hackers can do anything according to their needs. They can easily copy a file, then clone a drive, mirror an entire system. They can do anything perfectly, bit by bit, in classical computing. But in quantum physics or quantum communication networks, this is just impossible. This is impossible because in case of quantum communication networks, what is done? Information is encoded into quantum particles, like photons. Photons are quantum particles. You know this thing. So information is encoded into quantum particles. Meaning what? Meaning of this is that they can exist, these quantum states, they can exist in superpositions. Not can, better to say they exist in superpositions. They actually represent multiple possibilities at once until measured. Okay, so we are actually talking about here how nature prevents this act of copying. Why we are saying that this is impossible? Okay, copying is impossible. Why we are saying that? Because of one theorem. In 1992, Wouters and Zurich, they formulated one theorem known as No-Cloning Theorem. No-Cloning Theorem. According to that theorem, it states that it is impossible to copy, better to say it's impossible to create an identical copy of an unknown quantum state. It is impossible to create an identical copy of an unknown quantum state. That means if you do not know anything about the quantum state, means information about the quantum state is not known, then you cannot duplicate that state. And if you try to do that, that means you are actually trying to disturb the system. You are actually disturb the system. That way, if you try to duplicate that quantum state, you do not know anything, any information about that quantum state, and you are trying to copy. You are trying to copy that quantum state. In that case, you are actually disturbing the quantum state. That means this is an act of measurement. And you know that when there is an act of measurement, that means the quantum system, quantum state collapses. Okay, the quantum state collapses. And that is actually detectable. In case of quantum communication networks, that is detectable since quantum states collapses. Right? So this thing actually used, you know, QKD, quantum key distribution. Alice and Bob, two parties are there, and a secret key is shared between these two parties, Alice and Bob. That means they are also using the same thing. Say, for example, photons are being used by them, and those photons are carrying the information. So if there is one hacker, say for example, if that hacker tries to intercept or the copy that data or the quantum state of those photons, in that case what happens? Since she is female, okay, since she is trying to copy that quantum state, that means she is actually disturbing the quantum state. and that is actually immediately detectable, because in that case there is error occurs. Okay, since there is a collapse of the quantum state, so error occurs, so there is a rise in QBER. That means a quantum bit error rate, that is a rise. And just by noticing the rise, okay, Alice and Bob immediately detects the act of copying, because there is a rise in QBER. And that way, actually, in that case, what happens? That quantum key is actually compromised. So you can see here, since the act of copying is immediately detectable, instantly detectable. It is detected instantly. Whenever Eve is trying to copy that quantum state, the same thing happens here. Because C is actually disturbing the quantum state. This is an act of measurement which collapses the quantum state. And therefore there is a rise in QBER. QBER is a technical term. Okay, regarding this I'll make a separate video. QBER, QBER, that means quantum bit error rate. And just by noticing that quantum bit error rate, since there is a rise, that means someone is trying to do such a mischief. Okay, or there is some error in the system, immediately that encryption key is compromised. Or better to say here that key is rejected. So you can see physics itself is preventing this act of copying. Okay, so in QKD this is used. Not only in QKD, many things are there, and for those things I'll make separate videos. Okay, so just what I tried to explain here in this video, that in the world of quantum physics, nature itself prevents act of copy. This is the advantage. This is not a technology. Known as here, it is quantum, no-cloning theorem. Cloning is not possible. Cloning is impossible. Cloning means what? Creating an identical copy of the same thing. Here we are talking about quantum states. Anyway, so this was all about today's video. If you found this video interesting, so please like, share and subscribe to our channel. This is the end. Thanks for watching.